Well, hello there, distance learners. Let's go ahead and get this party started, everybody. Here's our warm-up today. Whoop. I want you to make a coordinate plane going 12 each direction and graph those figures onto it and ask yourself, are they similar? If so, what is the scale factor? You might not need to pause because I actually have to do this with you. So, here we go. No. Here we go. All right. Let's see here. So we need 12 this way. 1, 2, 3, 4, 7, 8, 9, 10, 11, 12, and 1, 2, 3, 4, 7, 8, 12, 4, 5, 6, 12, 12. -6, 1, 2, 3. Thank you so much, Job. And -4, -6. Wait a minute. Yes. -4, 0. -1, 3. -7, 3. -10, 0. And that's going to be J. Back to J. And then we're going to do Nicola over here in green. -4, -1. -6, -1. -11. Or so 11. What the? 6, -1. 1, 2, 3, 4, 5, 6, -1. That makes more sense. And 11, 4. 11, 1, 2, 3, 4. And then 11, -6. And -4, -6. And that is wait a minute, Nico. Where's L? I missed 6, -12. 3, 4, 5, 6. Okay, everybody. Can I get you back up here in 5, 4, 3, 2, 1? How many of us have got that figure onto our papers, guys? How many of us have got that figure on our papers just like this? Are you guys doing okay with that? Good, good, good. So, when you talk to your partners, and I apologize for that taking forever. When you talk to your partners, guys, do you think those two figures are similar? Yes with a thumbs up, no with a thumbs down, maybe with a thumb to the side. Where are you guys? Where are you guys? I see thumbs up, and I see thumbs down, and I see a few thumbs to the side. I like it. That's what I like to see. I'm going to copy this page. So I have to see here. Let's see here. So I'm going to need 3 of them. So let's do that again. In 5, 4, 3, 2, 1. Okay. Somebody who says that they think that these are similar. Can someone tell me why they think that they are similar? Tate, why do you think they're similar? Is it 0.6? 1.6? 0. So if you multiply the side lengths of the large figure by 0.6, you're going to get the side lengths of the small figure. Well, how do you know that? Like, what's... Yeah. So that's how it would be, because if I multiply something by 0.6, it's going to get smaller. Can you give me an example of that happening? So, guys, I want to hear. So NA here on Nicola, 1, 2, 3, 4, 5. And if you multiply that by 0.6, what do you get? 3, and there's 1, 2, 3. That looks good. Let's see if that works for CO. CO is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so, if CO, by the way, if these are matching up, guys, what side corresponds to CO over here on JSON? Which one corresponds to CO, everybody? HS, I agree. Kind of that weird pointy thing, right? In this Texas-looking figure, yeehaw. Let's see here. So if we take that, so if we do 10, which is the distance of CO times 0.6, I get 6, and so SH had better be 6. 1, 2, 3, 4, 5, 6. There's one more that's pretty easy to check, and that's NI, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that had better be 6 as well. 1, 2, 3, 4, 5, 6. It is. So I checked the 3 sides that are easy to count. Now, Sean could actually check WH and its corresponding side, OL, to see if that worked, because he's got a tool in his tool bag that we don't have just yet. We are going to get that there by the end of next week. No, when we return from fourth quarter, we'll get into it, okay? So he could. However, those of you who say that it's not similar, by raise the hand, what makes you think that that's true, Jared? So you're saying this goes 1, 2, 3 down, 1, 2, 3 left. And this goes 1, 2, 3, 4 down, 1, 2, 3, 4, 5 left, because that's what would correspond to that. And this one goes 1, 2, 3 up and 1, 2, 3 right. This goes 1, 2, 3, 4, 5, 6 up and 1, 2, 3, 4, 5 right. I don't know, I got the same for these two. Didn't I? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh, no, I didn't. You're right. So something is amiss there. Now, guys, it turns out that these 2 figures are, well, let's see here, guys. What I would do with this is I would go ahead and we're going to see if we can figure that. Because the thing is the problem is those side lengths, right? I don't know what this side length is. 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 So what we're going to do is we're going to use translations, reflections, rotations, and dilations to see if they really are the same. So let's go ahead and see what we can do, guys. Will you open up your planners to page 88? It's look for the first signs of spring day. Yay! How many of us have already seen some of the first signs of spring? How many of us have actually seen those? McKenna, what have you seen? Those little, the little crocus flowers that pop up the very first. Oh, I see what you mean. Awesome. So someone's getting their petunias out or something. I like that. Liz, what about you? Same thing. I know my tulips are starting to pop up. You're starting to see those little green things. And I swear, like if you look, I look really close and I can't see anything. But when I look at the trees, I swear I see just like a hint of green there. Like they're starting to pop out. And I'm like, yeah, yeah. All right. Anyway, if you're at home, go look out a window, see if you can find any signs of spring. What is our first essential question? And I hope that I can get that from, that's going to be, Aiden, what's our first essential question today? Up here, Math 8 Honors. How can dilations help me prove? Yeah. That two figures are similar. Okay, everybody. So let's find out. So here's the thing, guys. I want you to look at the coordinates, and I'm going to pull these coordinates down. I'm going to pull these coordinates down here because the Tate was saying he thinks that these might be similar, and he thinks that they're going to be perhaps is a scale factor of 0.6 that would take Nicola onto Jason. So I want you guys to talk to each other. Why do you think I am not going to recommend that you go ahead and multiply all the coordinates of Nicola by 0.6? I don't think that's the best way to dilate it. Will you guys talk to each other? If I multiply all the coordinates of Nicola by 0.6, why is that going to cause problems? Why don't you guys talk about it and maybe even try a few and see? Why do you think multiplying all the coordinates of Nicola, even though it would dilate it by a scale factor of 0.6, why do you think I'm not going to recommend that you do that? Talk to each other, and here we go. Teach! But why? I mean, we could. There's nothing. I mean, -4 times 0.6, you can punch it in your calculator. Yours look very different indeed. I think maybe one of them got graphed incorrectly. But that's okay. Yeah. Because they should look similish, right? Because I wanted the question to be a hanging one. Okay, can I get you back up here in 5, 4, 3, 2, 1? Hey, I appreciate you guys talking about that, and I do think you guys deserve a point for it. Thank you so much, everybody. Hey, folks, why do you think multiplying all those coordinates by 0.6 is going to be a piercing pain? Why is that going to be obnoxious to do? Go ahead, Tate. Yeah, look at this, guys. If you just try it with n, and we're going to dilate that by a scale factor of 0.6 to see if Tate's correct, which, by the way, I think he got by doing HS divided by CO, and that's how he got the 0.6 to check for that scale factor. If you do -4 times 0.6, I get -2.4, and -1 times 0.6 is -0.6. So congratulations, n prime is -2.4 comma -0.6. Does that make you feel happy? No, and do you guys think you might mess up your graph a little bit when you're making that dilation? Yeah, so if you're going to dilate a figure that way, what I recommend is that you first move it to the origin in some way, okay? Yes, go ahead.
So, the green shape, like, it's green.
Yes?
Name for that?
What?
Like, is there a name?
Oh, it's just a 1, 2, 3, 4, 5. It's just a hexagon. Okay, so here's what we're going to do. Grab your parchment paper, guys. And I got to get this going for you on distance learners. Hi, guys. All right. I hope this works. I hope you guys can see that okay and hear me okay. I'm going to try to put that on like that. All right, everybody. Hey, guys. 5, 4, 3, 2, 1. What we're going to do, guys, is we're going to take our parchment paper and we're going to put it over Nicola here. And go ahead and trace Nicola. Oh, wait. Let's stay out of the recording zone. Here we go. Sorry about that. Okay, here we go. Great. I wanted to just make sure that was okay. Here we go. Was that, hold on, was that the kill zone? Let me see. That was the kill zone. We're going to have to start over. Let's see here. Blah, 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 blah. You wouldn't be able to see someone here, right?
Yeah, you would. Because she came past the smart board.
She was probably right here, though. You might have... I didn't even see her face from where I'm
Crap.
sitting in person.
I'll investigate. Okay, anyway, so we're going to go ahead and trace Nicola.
Not Mr. Peterson trying not to get sued. I really hope that's not a recording.
It did.
Is that the portrait?
Oh, yes. Oh.
Mine just barely fits.
Barely.
You feel me?
Oh.
I guess so.
Thank you.
There's an extra one.
Okay.
It's for the viewers.
Oh,
Actually,
no.
I don't know if I get mad if I put that there.
Is it slightly insane that I'm trying to work on this time on Instagram? Yes.
Okay, here we go, guys. Can I get you in 5, 4,
It's new here, though.
3, 2, 1. So if we've got a figure like this, guys, if we've got a figure like this, in order to dilate it by a scale factor of 0.6 and to get nice numbers, I have to move one of the vertices to the origin. Which vertex do you guys want me to move to the origin? You guys want me to move N, I, C, O, L, or A? N? Okay. So if I move N, I go up 1 and right 1, 2, 3, 4. Now guys, you'll notice that takes this out of my graphable range. But that's not a problem because I know how translation rules work. The best part is this makes it look like I'm getting sucked into a black hole. Watch this. Ah! All right. So if we move Nicola up 1 and right 4, you've moved N to 0, 0, because remember, that means that we're adding 1 to all of our y values and adding 4 to all of our x values. In fact, got a pencil? Let's go ahead and write down the coordinates of those. That's going to take n prime to 0, 0, I prime to 10, 0, C prime to 15, 5, O prime to 15, negative 5, L prime to 10, negative 11, and A prime to negative 4, or sorry, for 0, negative 5.
Do you want all of it?
Yes. Yeah. Now, theoretically, because the thing is if Nicola and Jason are similar, when I dilate Nicola by a scale factor of 0.6 to get some of the sides to match up, then all of the sides should match up. And if they don't, that's a problem. So let's go ahead and multiply all of these by 0.6, which means that's going to take 0, 0. I double prime, let's see here. What's 10 times 0.6? Hey, give me that. Give me that. Give me, what's happening right now? There we go. 10 times 0.6 is 6. 6, 0. C double prime is 15. What's 15 times 0.6? 9, comma. Let's see here. Where did that go? 5 times 0.6 is 3. O double prime is, well, 15, we already know that's 9, and negative 5 should go to negative 3. 10, we already know, is 6. Negative 11, I don't know. Negative 11 times 0.6. And I'm just multiplying all these to dilate it. That is a bad sign. Negative 6.6. And that's L double prime. And then A double prime's at 0, negative 3. Yeah, indeed. Because the thing is, guys, do all of Jay Sean's points land somewhere nice? Do all of Jay Sean's points, do any of them land on some weird decimal? Yes or no? No, Jay Sean doesn't land on any weird decimals. But when we dilated Nicola at the origin, do some of them end up on decimals? Which means if we start translating and rotating it, it's probably not going to work out. But let's graph it just to be sure. So I'm going to graph O double prime here, or sorry, N double prime, and then 1, 2, 3, 4, 5, 6. And then 9, comma 3, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, comma 1, 2, 3, 9, comma negative 3, 6, comma negative 6.6, 1, 2, 3, 4, 5, 6, comma 1, 2, and a little bit, I guess, and then 0, comma negative 3. That does kind of spell it out, doesn't it? Does that look like it's similar to Jay Sean? Yes or no? It's suddenly starting to look a lot worse. So let's go ahead and see if our instinct is correct. Oh, there we go. Okay, so we're going to take our parchment paper, which I left on your guys' desk. We're going to take Jay Sean. Sorry, well, the new Nicola here.
How did you do that? Magic. Did you fold it? Huh? Did you fold it? Yeah. But in a special way. So many funny folds. Like a little diamond.
Okay, and let's see if I can get a little help out there. How about from Johnny? How would I try to move Nicola onto Jay Sean over here?
Whoa. How did it end up inside there? Wait, how did you do that?
Sorry, guys, I'm trying to hear Johnny. Sure. How many degrees? 270 degrees counterclockwise, so that's 1, 2, 3 quarter turns. I like it. Reflected across the x-axis. Yeah, that's okay. And then translate it, right? 1, 2, 3, 4, 5, 6. 1, 2, 3. Oh, look at that. Those ones are off by 1. So you now know for sure that these are not similar, that they don't match up. That even though the flat parts matched up okay, these little parts right here really messed that up for us. Wow. All right. Isn't there a spell in Harry Potter to make you like disappear and like go away? Is that apparate?
Why do you know these things?
All right, guys, cast that spell on me. Oh. Ah. All right, everybody. Can I get you back up here in 5, 4, 3, 2, 1? What a disappointment. Maybe we should do one that actually is similar. Got a pencil? All right, everybody. Let's see here. There we go. Make a coordinate plane that goes 8 by 8. 8 by 8. Eight every direction. Yeah, sorry. 8 every direction.
Thanks, that's why we're friends. What you did.
Okay, and here we go. I need 2 students. I think, nope, that won't work. And, okay, I got it. Johnny, what's your favorite color? Green. Didn't I ask you that yesterday? Did we already use you for a shape? Then I better not. Let's see here. Let's do. Nope, that won't work. Yeah, I was like looking at George, and George was like, nope. NDR. Oh, wait. Andreas, what's your favorite color? Blue. So we're gonna make ANDS. I know. It's the best I could do on an empty stomach. -6, 1. N's gonna be at -6, 5. And then 2, 5. At -2, 1. Let's go ahead and graph Andreas on here. It sounds like the argument that those 2 dudes were having in Inside Out. That's my hat. See, it says my hat. No, my hat says my hat. All right. Now I need somebody who I can write their name without an A-N-D or an S. An A-N-D or an S. I need an S for your name. Let's see. Oh, yes, indeed. Here we go. Because I could do L-I-Z-Y. Yes. So we're going to go. Liz, what's your favorite color? Purple. That's my daughter's favorite color also. L-I-Z-Y. When did you guys start calling Liz Lizzie? Well, we were trying to prove that she was similar to Andreas, which is also why we call him Ans. All right, and there's Lizzie. Let's go ahead and get Liz on there. So 3, -1, 2, -1, 2, -2, and 3, -3. It's itty bitty. Okay, can I get you back up here in 5, 4, 3, 2, 1. Here we go, folks. I'm going to tell you right now, in the interest of time, these 2 figures are similar. Will you guys please go ahead and prove it by dilating one so it is the same size as the other one, and then moving it around the coordinate plane so that they match up perfectly. I'm telling you that these are similar. I want you to prove it and also write a similarity statement for them, please. Go ahead, guys. Give it a shot. And here we go. We got this, Lizzie. Teach.
We got this, Lizzie. Okay. Yeah, how are we going to get this to work?
I just not know how to draw. Well, with magic, of course. Or maybe I just don't know how to graph.
They should be similar. I hope I'm not that much of a fool. Let's see here.
It's so tiny.
Yeah, they're similar. They're similar. Yeah. No. They are similar, but you guys have to still come up with the instructions on how to dilate, translate, reflect, and rotate one so that it matches up with the other one. Guys, let's keep our hands to ourselves, please. So I'm telling you that they're similar, so can you find the scale factor between them? Is it what? It is, yes. So if you multiply these by 0.25, you'll get something that's this long. Now, That's not going to be very helpful because 6 times 0.25 is negative 1.5. No, thank you. So I would translate this to the origin, just one of the points. It doesn't even matter which one. And then you can shrink it down like that. You could also go the other way, because the scale factor from here to here is 0.25. So what's the scale factor from here to here? Let's figure it out. Let's figure it out. Keep going, everybody. In 1 minute, I'll go ahead and show you what I would do. Everything okay over here? So yeah, put that on there, down there. So you put this on here, and then you specifically tell me what you're doing to move that on there. Like, are you rotating it? Are you translating it? Reflecting it? I know you guys become my little number crunchers. Just wait till the statistics unit. That really gets it going. Okay, everybody. Can I get you back up here in 5, 4, 3, 2, 1. Settle in. Folks, I noticed that a lot of you noticed that the scale factor from Andreas to Lizzie is 0.25. But if you go the other way and you ask, well, what is NA divided by IL? That's 4 divided by 1. The scale factor from Andreas to Lizzie is actually 4. And since that's a much nicer number, I can actually multiply all of Lizzie's coordinates by 4 and do that for free. So if I multiply all that by 4, so if I dilate Lizzie by a scale factor of 4 centered at the origin, then we get the figure L prime, maybe, there we go, at 12 comma negative 4, and don't worry that it's off of our graph, that's okay. I prime is at 8 comma negative 4, Z prime is at 8 comma negative 8, and Y prime is at 12 comma negative 12, which I'm going to go ahead and graph as best I can in the small amount of time that we have left. Yeah, that works too, especially if we know that they're, in this case where I tell you that they are similar. Let's see here. So, I put that down. Annalise, don't whisper in the distant corners when I can't see what you're saying. All right, so we have 12 comma negative 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, 3, 4. And then 8 comma negative 4, 1, 2, 3, 4, 5, 6, 7, 8. Well, 12 comma negative 4 is where that's going to be. 1, 2, 3, 4. And then 8 comma 4, so negative 4, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4.
Ooh, you gotta get into your ears. You gotta
And
get
then 8 comma negative 8. Hang on, guys, we're not done yet. We're not done yet. Don't go packing up on me. And then negative, or 12 comma negative 12. I just barely ran out of room. I'm like having bad luck with that today. Now we've got to figure that's the right size. And we can go ahead and
watch this now.
Annalise, are you messing with that?
No, I didn't touch anything.
Did you show them something on your phone?
I didn't.
Are you gonna get me in trouble?
No.
I'm genuinely worried about this right now.
I'm just doing ASMR.
Rotate it 90 degrees around the origin, and then you can translate it and get something that matches up, okay? There is a self-assessment that's just like this, guys. Do the best that you can. Distance learners, there's something weird on there. Will you please let me know so that I don't get in trouble? And then have this happen to my job?